Hello, my name is Warren Daniel and I am with Commercial Level Simulations. And what we have here is the CLS VLJ flight training device for the Eclipse 500. Now this is going to be our first full video showing tips and tricks. We've had a number of questions which come from customers. The questions are oftentimes very similar. How do I do specific functions in the simulator? So we wanted to take this chance to make our first time video to show these specific features. Okay, the three topics that we're going to cover in this video are use of the brake pedals, how to apply the brakes. Secondly, we'll talk about the autopilot of our CLS VLJ flight training device and how it relates to the Eclipse 500 autopilot. And lastly, we'll talk about the virtual air traffic control network which is out there, which is called VATSIM. Since your CLS VLJ flight training device is a PC-based simulator, you can connect it directly to the internet. By doing that, you can actually use our simulation and be part of the larger interactive environment out there where you communicate with other pilots, air traffic controllers. Everyone are in these different positions, whether they're air traffic controllers for center, clearance delivery, approach, departure. You can listen to ATIS frequencies and things like that, which is very, very interesting and puts you in an immersive environment. Okay, so for the first thing we'll talk about today are the use of the brake pedals. We get several questions from customers about the takeoff distance of the Eclipse 500. Now, the first thing that you would need to do is to consult your AFM and your QRH. In your performance documents, it will list out specifically the distances required for takeoff and landing. Does it make a difference in our simulator? Yes, it does. Various airports have longer or shorter fields. So depending on where you're taking off from, obviously consult your airport charts to verify that you have enough space for takeoff and landing. Next, does altitude make a difference? Yes, it does. Taking off from sea level produces a different acceleration rate than if you're taking off in thinner air, such as like a high altitude airfield. So taking off from sea level, for instance, close to sea level at some place like Van Nuys or an airport such as like Fort Lauderdale would be different than actually taking off from Albuquerque. The next question is, does the weight of the aircraft make a difference? And yes, it does. Remember, in your CLS VLJ flight training device, there are two areas where you would enter your weight. First is you would change the physical characteristics of the airplane, which you basically load the seats, you load the baggage areas, the weight stations. And then next you would actually change, just like in the real airplane, you would on the MFD. When you go to the ops page and you change the weight settings for the various seats, that will help you calculate your V speed, so your VR, VREF, VYSE, and some of your other speeds. So now we're going to talk about one of the main questions that we receive from customers is how to operate the brake pedals.
Another common issue experienced by new customers is taxiing or attempting to take off while riding the toe brakes. Use the rudder pedals to control your direction. However, we have observed customers unconsciously riding the toe brakes by pressing their toes downward as they attempt to taxi or take off. We recommend making sure that your toes are completely up to release the toe brakes. The next area we'll highlight is our autopilot. We often receive questions on the functionality of the Eclipse 500 autopilot and our FTD. On the Eclipse 500, up to Avio NG 1.5, there are in-op stickers on various autopilot buttons. However, in our CLS VLJ flight training device, all of the functionality currently works with the exception of the Alt Change button. Because our autopilot and auto throttle are functional with features such as ILS and localizer approaches, GPS navigation, MCT climb, and speed hold, please be certain to watch the FMA on the PFD to clearly understand what flight mode you are in. Keep in mind, depending on what button you have pressed, as you become familiar with your touchscreen flight training device, you could be in a flight mode not supported by an Eclipse 500 below Avio NG 1.5. As we mentioned before, although CLS added a visual in-op sticker, the functionality of the auto throttle works. We recommend flying your FTD without use of the auto throttle as you prepare for your type training. However, to practice flights for upcoming Avio NG functionality, once airborne, simply select your desired airspeed with the airspeed select knob, then press the auto throttle on button to engage the auto throttles. Disengage the auto throttle by pressing the auto throttle button, the AP disconnect button, or the all interrupt switch. We changed our original functionality to a new format with this latest software package. So just simply ensure that your throttles are set for full thrust or idle positions when you engage the auto throttle button. The approach button is functional as well. With the runway course and ILS frequency set, simply press the approach button to intercept the localizer and glide slope. The nav button works with a previously entered flight plan. Please see our user's guide on how to enter a GPS flight plan without the use of Garmin 400 GPS units. Switch the PDF soft key to CDI GPS 1, then hit the nav button to follow the LNAV FMS waypoints. We'll have a demonstration of this when airborne. The highest number of questions we receive from customers new to our FTD and the Eclipse 500 is on the functionality of the Autopilot pre-select knob, the Alt button, and the pitch wheel. At CLS, with various reports coming from different customers, we needed to strike a balance between our software and the current capabilities of the Eclipse. Climb and descent in the Eclipse is accomplished by placing the aircraft into pitch mode. Select the altitude you desire with the altitude pre-select knob, then use the pitch wheel to adjust your pitch angle. The CLS VLJ Autopilot will climb, level off, and capture the pre-selected altitude if we use both the altitude select knob and the pitch wheel. Let's do a demonstration of the pitch to climb capture function. First, select your desired altitude with the altitude pre-select knob. In this case, we'll set 3,000 feet after takeoff. After takeoff, engage the autopilot. Then, use the pitch wheel to adjust your vertical pitch angle. Within 200 feet of the target altitude, the autopilot will begin leveling the nose and will capture the pre-selected altitude. This will result in the green Alt message displayed at the top on the FMA.
In our next example, now let's say you want to actually increase your altitude now from your target altitude to a new altitude. So now we'll actually go from 3,000 feet to 5,000 feet.
In this case, we start where we left off, flying straight and level at 3,000 feet with the autopilot engaged. Next, we increase our altitude by turning the altitude pre-select knob. As you can see, the autopilot has not yet begun a climb to our new altitude of 5,000 feet. It will remain at our current altitude until we press the pitch wheel. As we rotate the pitch wheel for the flight director to indicate 10 degrees nose up, notice the autopilot now increases the nose pitch angle and we begin our climb. As we approach our target altitude to within 200 feet, the autopilot will level the nose and capture our new altitude, again with a green Alt capture and Alt message on the FMA.
Now, one thing that we do want to point out is that excessive high rates of climb, for instance, if it's from either excessively high vertical climb per minute rate or climb descent per minute rates, or excessive nose up or nose down pitch rates, the autopilot will actually go to the target altitude, attempt to capture. However, it could actually blow through the intended altitude simply due to like the energy of the climb or the energy of the descent. And this is typical of what you would see on the actual autopilot, the aircraft's autopilot itself. However, the autopilot will climb to that altitude. It will overshoot slightly because of the energy of the climb, and then it will actually come back and descend, recapture that target altitude.